we can see the screen.
तो बच्चा कल or till yesterday we finished the question type number 5 and 6. तो क्या देखा उनमें? So we came across situations wherein in 5 you had a rigid body which has the length, breadth, width significant enough, and we wanted or we understood how do you apply the conservation, the not the conservation, but the equilibrium condition, the sum of all the forces along the horizontal, along the vertical to be zero, and the sum of the torques around the z-axis to be zero. Why do I talk about the z-axis and not so much about the x and y? Because typically at this level, in the situations that you are given, the forces are in the xy plane. So which means that we are only, the only torque that there can be is a torque about the axis perpendicular to that xy plane, perpendicular to the plane in which you have the forces. So that was number 5. And then the number 6, we started working with problems wherein you have mass along an inclined plane. What makes the inclined plane so special? Well, the forces are at an angle to the horizontal or to the vertical. So you don't just have the forces along the horizontal and vertical, but the forces now are in or are at an angle to the horizontal or to the vertical. So it's all about building that ability to resolve components of forces along the, say, horizontal and vertical direction, and then write your summation fx equals to 0, summation fy equals to 0, or net force along a direction equals to ma. It's something that we will dive into when we start dealing with the accelerating scenarios where the masses are undergoing acceleration. Okay, let's talk about what we're going to discuss today. We're going to discuss question type number 7. What do we have in 7? Now, in 6, you only had one mass on the inclined plane, but in 7, you have two masses or more than two masses along the inclined plane. And we are interested in understanding the contact forces between the two, okay, or the forces, force that one is exerting on the other. Then in number 8, we will look at a scenario which seems to be a slightly complicated version of the inclined plane. What do I mean by that? So in inclined plane, the slope of your incline is the same everywhere, right? Tangent theta, theta is constant. But now here in the curved incline, now the slope is changing at different angles, okay? Then in the scenario number 9, that's the target as well for today, we will look at the scenarios wherein the particle is moving at constant speed. What you have to remember is, if a particle is moving at a constant speed, that means the acceleration is 0. If the acceleration is 0, that means the sum of all the forces must be 0. Okay, so then again, the particle is in what we can call as a dynamic equilibrium. Okay, so let's see if we can finish all 3 today. So let's start with number 7. So now let me just discuss some of the intricacies of the scenario so that you can start to think along those lines. And then we'll jump into some practice questions for us to hone that skill or get the comfort level. Okay. So let me just and while it's coming up, any questions, Chavi or Ruchika, you guys have from the discussion yesterday?
No, sir.
No. Okay. Do remind
So,
yeah.
so वो एक क्वेश्चन हुआ नहीं था ब्लॉक वाला.
I was just gonna say, do remind me to touch upon that question on the block. We had solved that question, Chavi. I may not have emphasized that we had solved it, but that is a fundamentally important question. About that sometime towards the second half of the class. ठीक है बेटा, उस क्वेश्चन को छोड़ना नहीं है, पक्के से दोबारा रिविजिट करना है. पहले यहां से जर्नी चालू करते हैं, फिर बिफोर द एंड ऑफ द क्लास विल गेट टू दैट क्वेश्चन. अच्छी बात. तो व्हाट डू वी हैव हियर? दो मैसेज हैं. नाउ लेट्स लुक एट दिस सिनेरियो. गिव मी अ सेकंड. Let's look at this scenario first. So we have M1 and M2 along the incline. Okay. Now, under what circumstances would M2 be exerting some force onto M1? In other words, under what circumstances would there be a contact force between M1 and M2? Given that both the masses are stationary, they are not moving. They are not moving. Well, M2 will exert force on M1 if, so let me quickly draw the forces on M2. This is my M2G. This is my M2G. This is the normal force. This component of M2G is M2G cos theta. And this component is M2G sine theta. If the frictional force or the frictional, the coefficient of friction is mu2, then this is my frictional force. Then if mu2 is less than tan theta, which implies that mu2 mg is less than mg sine theta by cosine theta, or we can write this as mu2 mg cos theta is less than mg sine theta, meaning the maximum force, the maximum frictional force, maximum static frictional force is less than the force, the component of the gravitational force acting along the incline. Okay. So if that is the scenario, what does that imply, Chavi, Ruchika? It implies that the mass M2 will be pulled downwards by the gravitational pull and the static frictional force will not be able to stop it. Yes, in that case, M2 will slide. But क्या इसमें given क्या है? Given ये है that M1 is not, the M1 and M2 are stationary there. So what does that mean? That means that in such a scenario, M1 must be providing that push up the incline to stop the movement of M2, right? So what will be the normal force between M1 and M2 in that scenario? Well, the normal force in that scenario would be M2G sine theta minus mu2 M2G cos theta. ये बात तो बड़ी सिंपल सी है, सीधी सीधी बात है, कोई कंफ्यूजन तो नहीं बेटा? छवि, रुचिका, बेटा कोई कंफ्यूजन तो नहीं? तो अब M1 का अगर मैं फ्री बॉडी डायग्राम बनाऊं, if I were to draw the free body diagram of M1, what will I have? I'll have this. So here is my M1. The gravitational acceleration or the pull is M1G. This is M1G sine theta. And then there is a normal force acting in this direction. The frictional force acting is in this direction. Normal force is acting in that direction. In other words, कितना friction force लग रहा है ऊपर की तरफ? Well, F is equals to M1G sine theta plus n. N is this, right? So if you substitute that in this equation, you will get the expression for the frictional force. Given that the two masses are stationary, it is but obvious, given सी बात है, simple सी बात है, that this frictional force must be less than this F must be less than equals to the maximum frictional force acting on mass M1, which is how much? Mu1 M1 G cos theta, right? बात clear? Yes, beta?
Yes, sir.
Okay. Now, if we were to replace this scenario with this one, wherein what's so different about this scenario? Earlier, they were just touching each other or pushing each other, right? But now you have a rod connecting the two. So in the left scenario, M2 could only push it, right? It could not apply brakes on M1. In other words, if M1G sine theta, if M1G sine theta were to be greater than mu M1G sine theta, in other words, if mu1 were to be greater than tan theta, there was nobody to stop M1 from sliding down. Correct, no? But now, when you introduce the rod between the two, then M2 can also apply the brakes on M1. Correct, no? Because now the rod is there, so now there can be compressive or the tension force between the two. Yes? So M2 can, so M1 can experience tension this direction, or it can experience tension in this direction, downward direction, right? If M2 was pushing it, then the force that M1 is experiencing due to the rod is downwards. If M2 is pulling it upwards, but M2 is applying the brakes, then the rod will be pulling the M1 up the. सुनने में थोड़ा सा कॉम्प्लेक्स लगता है, but इतना बड़ा कॉम्प्लेक्स है नहीं. It definitely sounds complicated, too many words, but if you think about it, it's not that complicated. Shall we go ahead and start with the questions?
Yes, sir.
Yes, sir.
Okay, beta. Again, the same rule. We'll try and do 2 or 3 questions. One NTA, one JEE Advanced, one JEE Mains. We'll do all the recent ones. Let's start with 2004 question, JEE. Well, there are no 2 blocks in this scenario. This should have been in the previous question type, but that's okay. For students joining us on YouTube, जो बच्चे हमें YouTube पे join कर रहे हैं, who might be listening to this session, तो बेटा आप ये क्वेश्चन करें. अपने इन सेशंस का पूरा फोकस यही है कि फिजिक्स is just like any other skill. The more you practice, but in a structured manner, the quicker you will build that skill to solve problems. And very soon you will find yourself solving even very complex problems. तो बच्चा ये क्वेश्चन करें JEE Main का.
Sir, 2 आ रहा है.
Let me go back into the live class. 2, okay, 2 kgs. रुचिका बेटा आगे बढ़ जाएं.
Yes. Yes.
Let's do one NT अभ्यास question. For students on the YouTube, by the way, the live class is not able to hear my comments now. Beta, इसमें there is no friction force between 2m and the slope, right? So the 2m mass can slide down, right? So we're talking about the limiting angle of theta at which it just starts to slide. That means theta at which just brakes लगे हुए. कौन लगा रहा brake? Frictional force acting on mass B, right? Which is acting up the incline. So that frictional force has to support or has to fight 3 mg sin theta. क्यों कहा मैंने 3 mg sin theta? बेटा थोड़ा सोचेंगे तो you will get it, right? B का है mg sin theta acting downwards, और A पे अर्थ और ग्रेविटी इज पुलिंग इट डाउन along the incline by 2 mg sin theta. दोनों फोर्सेस को, जो एक्सटर्नल फोर्सेस हैं, उनको फ्रिक्शनल फोर्स को निगेट करना है. अगर इफ यू आर नॉट कंफर्टेबल थिंकिंग अबाउट द प्रॉब्लम इन दिस मैनर, then do it by block. Draw the free body diagram of individual blocks, write down the forces, and then try and solve it. Okay? So either way is fine. Whatever works for you. Let me check back into the live class now. Yes, Chavi, Ruchika beta, how are we doing?
So just a second, almost done.
Almost done, okay.
So
So CR.
Yeah, 3 mg sin theta is equals to mu mg cos theta, or tan theta is 1 by 6. Let's look at the JEE advanced question. This is a good question. Karimida. Just note that you have been given the value of tan of 5.5, tan of 11.5, tan of 16.5. ये given. जो स्टूडेंट्स यूट्यूब पे हैं, note that there is no frictional force between m1 and the incline. If I read that right, yes, it says the coefficient of friction between the block m1 and the plane is always 0. Okay, so acha, and both of them are stationary, they are not moving. Oh, they may be moving. They're just asking for the friction between the M2 and the incline for different angles of theta. Logic क्या है? Obviously, the frictional force is acting between the M2 and the incline. What will be the magnitude of that? Well, the maximum magnitude is mu M2G cos theta. Right? Maximum is mu M2G cos theta. Mu is 0.3. M2 is 2, so that's 0.6 into G, which is 10, so that's 6 into the cos theta, right? So 6 cos theta, that is the maximum. And when would we have maximum kick in? When it's about to slip. That 6 cos theta or mu M2G cos theta has to fight the M1 plus M2G sin theta. Right, so when m1 plus m2g sin theta is equals to mu m2g cos theta, that's the maximum about to slip situation. And when will that happen? You can figure out the tangent theta at which that happens, right? Below that angle, below that critical angle at which it's about to slip, below that critical angle, kitna force lagega up the incline, friction force? Well, friction is a static friction force. It just has to oppose the applied, that the counter force, the force that is causing the two to slide, right? The incline or M2 to slide on the incline. So what will that be? That will be M1 plus M2 G sine theta. So for all the values of theta less than the theta critical, the friction will apply M1 plus M2 G sine. Okay, so let's look at.
Sir, आप एक बार options दिखा दें.
Yes, Peter. Peter, can it be M2 G sine theta under any circumstance?
No, sir.
No,
It has
sir.
to be. It can either be M1 plus M2 G sine theta, or it can be equals to mu M2 G cos out to slip scenario for theta critical angle that will be there is no such thing as 4. 4 तो है ही नहीं, सिर्फ 2 and 3 हो.
Sir, I'm getting D option.
You getting B for Bombay or D for Delhi?
D for Delhi.
D for Delhi.
Yes, sir.
Okay. Critical angle कितना है बेटा आपका?
Sir, approx 11.5.
11 point. Yes, Chavi beta, you're okay?
Sir, एक second.
Sure, sure. Take your.
Yes, sir. हो गया.
By the way, when you guys are approaching the question, जब भी आप कोई JEE एडवांस जैसा क्वेश्चन सॉल्व करते हैं, तो पहले तो कहीं ना कहीं मन में आता होगा ये तो JEE एडवांस का क्वेश्चन है. आता है बेटा छवि?
कभी कभी.
कभी कभी, right? तो जब भी ऐसा आए ना, नोट करें कि आपका माइंड क्या करता है. इज इट डूइंग 1 2 1 2 आगे पीछे आगे पीछे आगे पीछे, या is it trying to find that first thread of thought? पहला धागा पकड़ना है, वो पकड़ में आ गया तो पूरी रस्सी पकड़ना है. ठीक है, तो वो पकड़ना ही सीख रहे हैं इतने सारे क्वेश्चंस का. तो वी आर बिल्डिंग दैट एबिलिटी. देखते ही माइंड बोले आओ, आई नीड टू फर्स्ट लुक एट द फ्रिक्शनल फोर्स. व्हाट इज द फ्रिक्शनल फोर्स बिटवीन M1 and ground, the incline? 0. अच्छी बात. Then the friction force on M2 must be supporting, must be fighting the force on M1 plus M2 acting downwards. Okay, so below theta critical, the frictional force has to be M1 plus M2 G sine theta. At the critical scenario, it will be obviously mu M2 G cos theta. Correct ना बेटा? क्योंकि normal force तो M2 पे उतना ही है ना, कितना M2 G cos theta. The maximum frictional force will be mu M2 G. उस टाइम पे भी it will be true that it will be M1 plus M2 G sine theta, right? But beyond that, the frictional force अब लिमिट हो गया, mu M2 G cos theta से exceed नहीं करें. ठीक है, when the two are sliding down. तो हमेशा ये नोट करें, रुचिका बेटा आप भी नोट करें कि is the mind able to peacefully pick on the first thread पहला एंगेजमेंट चालू हो गया, उसके बाद अब इतनी ट्रेनिंग हो रही है आप लोगों की कि यू कैन फाइंड योर वे अराउंड द मेज। शुरू वाला थ्रेड पकड़ने में वो अगर या तो दिमाग कहीं खोया हुआ है, क्वेश्चन नहीं पढ़ पा रहा है, फोकस नहीं है, फिर वो पैनिक करेगा, बोलेगा अरे अरे क्या हो रहा है, टाइम जा रहा, टाइम जा रहा, टाइम जा रहा है, राइट। वो टाइम 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 क्यों करता है माइंड? क्योंकि वो फोकस नहीं कर पा रहा इन अ पीसफुल मैनर एंड इट्स नॉट एबल टू सी इट्स वे थ्रू। जैसे ही when the mind struggles to find its way through, it tends to panic. Anyway, next wala question type. Let's move on to the next one. So question type number 8. So now we're going to be dealing with the curved surfaces. So what's so special about the curved surfaces? Well, in the inclined plane, we knew that if the inclined angle is theta, then the normal force is m2g cos theta, and the force along the incline is mu m2g sin theta. Right? But now, or the frictional force, by the way, will be mu m2g cos theta up the incline. Now, in this scenario, when you're dealing with a curved surface, so the first question is, what is that sine theta? What is that cosine theta in this case? Right? Well, for any curve, what do we know? If the curve is given, let's say you are given curve is y is equals to x square, then what you can find at any point along the curve is a slope, right? And what is that slope, Chavi? Slope at any point along a curve, slope is dy by dx, right, beta?
Yes, sir.
Okay. Now, once you know the slope, let's see if we can relate that to our standard thetas. इसमें सारी डिफिकल्टी कोरिलेट करने की ही है थीटा को, दैट्स इट। बाकी तो प्रिंसिपल्स आर सेम। सो वी नो दैट दिस द टेंजेंट इज dy by dx at that point, right? dy by dx at, let's say this is x, or let me just draw the x here. Let's say this is x, this is y. Then for any given x, you first find dy by dx, or given the y is equals to some function of x, you first find dy by dx, and then you substitute that value of x. So you find the dy by dx, and what does that give us? That gives us tangent of this angle. We call it alpha. So this is equals to tangent alpha. Okay. Now, once you know this angle, then how do you figure out the forces along this direction and the forces, the component of the force in this direction? Or I should say, how do we figure out the component of mg along this direction and along the slope? Yes? If this is alpha, then this one is pi minus alpha. ठीक है ना बेटा? Correct?
Yes, sir.
Okay. So then this will become, so not m2, but simply mg cos of this angle. Right? And what is the other one? There'll be the sine component of it. ठीक है बेटा? So there'll be mg sine of pi minus. Okay? So that's one scenario. If you're given the curve and you have to figure out the components of the forces along the incline at a given point along the curve. Now let's say you are given this angle that the radial line joining the block or the particle to the center of the curve, assuming this is, let's say, a semicircular curve. If you know this theta, right, then can you figure out your angles, Peter? Well, if it's a semicircle, then we know that if I were to draw this line, then this tangent would be perpendicular to this radial line, right? Then again, it's fairly simple. Then this angle is theta, and you can again write your components of the forces. In that case, it will be mg cos theta, and again mg sine. I hope the last one made sense. Sorry about writing too much stuff in a small space, but मोटा शायद आप लोग पकड़ गए, right? दोनों सिनेरियो डिस्कस कर लिए. आपको अगर सिंपल कर्व गिवन है, which means you can figure out the slope at any point, and if you are given that the particle is at a certain point, then you can figure out your the components of the gravitational force along the incline and perpendicular to the incline, right? Because the normal force will be equals to the component perpendicular to the incline, and the frictional force will be mu times that value if the particle is slipping or about to slip. Yes, Peter? Just give me a quick second. Yes, Peter. Just give me a quick second here. Hi, good evening. Sorry, I'm in a class right now. Will not be able to take the call. Thank you. Bye. Okay. Sorry about that. I think we are clear on how to approach these. So let's go ahead with one sample question. The first one is 2021 question. So please go ahead and have some fun with this question. So for the students on the YouTube, बेटा क्या गिवन है यहाँ पर हमें ये उसका वो दे रखा है, इक्वेशन दे रखी है आपके इंक्लाइन प्लेन की y is equals to x square by 4. पूछा ये है कि if the coefficient of friction is 0.5 along that curved surface, तो हम कितना हाईएस्ट पोजीशन पे किसी एक पार्टिकल को रख सकते हैं without slipping, right? So we have to figure out that point where we are just going to get the about to slip scenario. बेटा आप लोगों को डिस्टर्ब तो नहीं होगा if I solve the question along with you guys on the screen?
No, sir.
Okay.
So
25.
yes, sir, 25.
You got 24?
25. I was going to say 1 by 4 meter, but 25. Yeah.
25 centimeters.
Yes.
Yes, sir.
Okay, beta. For students on the YouTube, beta, I have drawn the forces there. Now you just need to equate the forces along the incline. ठीक है, क्योंकि मूवमेंट जो होगी along the incline ही होगी ना, perpendicular to the incline जा नहीं सकता है ना पार्टिकल. Along the incline you will have mg sin theta is equals to mu mg cos theta for about to slip slant. That is tangent theta is equals to mu. So mu is given to be 0.5. X is equals to, this is interesting. Shall we beta just see how I have approached it and let me know if you see any issue with it.
Sir, I did the same thing.
Your answer is,
सर आपने x निकाला है
so okay, so we're talking about the height then. So y is 1 by 4. Got it. By the way, how did you figure out the unit of it, beta?
सर mg सब कुछ स्टैंडर्ड में है ना, g को स्टैंडर्ड में लिया तो
जी तो बेटा कटा गया वो तो. Yes, बेटा. Well, बेटा, it all depends on what is the unit of x. किस यूनिट में ये इक्वेशन जो दी गई है ये किस यूनिट में है. तो और अगर जो कांस्टेंट है नीचे वाला ना 4 जो है 4 की यूनिट्स क्या है. क्यों? y जो है that has the unit of length. x also has a unit of length. तो राइट साइड में यूनिट ऑफ लेंथ का स्क्वायर, लेफ्ट साइड में सिर्फ यूनिट ऑफ लेंथ है. दैट मीन्स 4 इज नॉट डायमेंशनलेस कांस्टेंट, इट हैज डायमेंशंस. 4 के क्या डायमेंशंस है वो पता होनी चाहिए, राइट? ठीक है बेटा, 4 के पता होने चाहिए, x के पता होने चाहिए. अब यह इन्होंने कहीं दे नहीं रखा है कि ऑल दी डायमेंशंस आर इन मीटर्स वेयर x एंड y आर इन मीटर्स. देना चाहिए, राइट? तो कोई बात है, नहीं दिया तो बिकॉज दैट्स द ओनली थिंग दैट मेक्स सेंस.
सर तो अगर कुछ नहीं है तो वी अज्यूम स्टैंडर्ड यूनिट ऐसा ही है.
बेटा ऐसे करना तो नहीं चाहिए अब, लेकिन कोई जी मेन में इतने सारे पेपर बनाते हैं ये लोग आजकल. कितने पेपर बनाते हैं? रफली अबाउट 24 पेपर्स बेटा ओवरऑल, राइट? 720 क्वेश्चंस छापते हैं ये लोग, राइट, एवरी ईयर. पहले पता है जो बुक्स आया करते ना जेईई मेन की, उनके अंदर पूरी बुक में इतने क्वेश्चंस नहीं होते थे जितने अब आजकल एक साल में आ जाते. It will be interesting to see कि अब वो बुक छापने वाले भी कैसे कोप अप करेंगे ना, कितना छापेंगे उसके अंदर. Anyway, ओके बेटा.
यस
ओके रुचिका,
Yes.
एक जी मैथ्स का देख लेते हैं. 2014 क्वेश्चन. It's very much the same question, so we can skip it. Yes?
Yes, sir.
Okay. रुचिका बेटा, एक चीज नोटिस करें, जो आपने आज या कल जो आपका एग्जाम था, if you relate the level of difficulty, then for example the previous जो आपने किया JEE advanced का क्वेश्चन, उसकी डिफिकल्टी भी वैसी सी है, मतलब इट विल टेक सम टाइम, ऐसा नहीं है कि देखते ही आपने इक्वेशन लगाई, थोड़ा बहुत सोचना तो पड़ेगा, ठीक है ना? सो if we are taking let's say roughly about 3 minutes to solve a problem, then we don't have an issue, right? तो अब 3 मिनट्स का मतलब क्या हुआ कि मान के चलें कि एक मिनट तो आपने क्वेश्चन को पढ़ने में समझने में लगा दिया, ठीक है? 2 मिनट बचते हैं आपको सॉल्व करने, जो भी कैलकुलेशन करनी है, सॉल्व ऑल द वे थ्रू। पहला मिनट बड़ा क्रूशियल, पहला मिनट बड़ा क्रूशियल। कैसे ऑप्टिमाइज करना है? जैसे जैसे क्वेश्चन पढ़ रहे हैं, जैसे जैसे क्वेश्चन पढ़ रहे हैं, स्टार्ट बिल्डिंग एन इमेज ऑफ इट, एन एक्यूरेट इमेज, राइट? माइंड में जैसे से लिखा इंक्लाइन, तो माइंड में एक इंक्लाइन ड्रॉ कर, क्योंकि वो पहला 1 मिनट बड़ा क्रूशियल है फॉर द माइंड टू गेट ए क्लियर अंडरस्टैंडिंग कि क्या चीज चल क्या रहा है क्वेश्चन क्या, राइट? क्वेश्चन क्या, क्योंकि नॉर्मली द अमाउंट ऑफ वर्ड्स आर 3 times you will see in JEE Mains, ठीक है? तो वर्ड्स बहुत सारे हैं, तो माइंड को इस लाइक छोटा ऐसे है आपको पढ़ने के लिए ना, और फिर आपको समझना है कि सिनेरियो क्या गिवन है, उस पर एक्यूरेटली समझना है, कहीं कोई गलत अजम्पशन ना हो जाए, अदरवाइज आप टेंजेंट पे निकल जाएंगे। तो पहला मिनट बड़ा क्रूशियल। अब पहला मिनट बेटा, 1 मिनट तो बहुत होता है, 60 सेकेंड्स अगर आप मैं काउंट करने लगूँ अभी, राइट, 1 2 3, तो आप बोलेंगे सर दैट्स टेकिंग वे टू लॉन्ग, राइट? और वैसे 1 मिनट निकलता पता नहीं चलता, क्लास 1 घंटे की निकल जाती पता नहीं चलता। तो वो तो व्हेन वी आर हैविंग फन वी द टाइम फ्लाइज, राइट? लेकिन 60 सेकेंड्स आर गुड एनफ टाइम, ठीक है? तो जैसे ही क्वेश्चन रीड करें, साथ साथ में क्लियर इमेज बिल्ड करनी, क्लियर इमेज बिल्ड। Now what do we have in these questions? So we have a single particle that is moving at constant speed, right? Once again, if a particle is moving at a constant speed, right? In fact, I should say the particle is moving at constant velocity, not just speed. If it is moving at constant velocity, right, then the acceleration would be 0. Yes, beta? The acceleration would be 0, which means that the sum of all the forces acting on the particle must be 0 as well, along x direction, along y direction, along z direction. Okay? So can we straight away jump into the question? By the way, ये जो पिक्चर ड्रॉ कर रखी है, this is one of the questions actually in the down below. I think it's a JEE advanced question. क्या गिवन है? आपको क्वेश्चन ना कई बार थोड़ा उलझा के देते हैं. They will not give the question in a straightforward manner, but rather, for example, let's talk about this one. They say a particle is being acted upon by a force which is given by A cross V, right? A cross V, where A is a constant vector, and that's it. That's your, and V is the velocity vector, right? And the particle is in equilibrium in the vertical direction. In the vertical direction में equilibrium है, horizontal plane में नहीं है, right? तो क्या समझें इस क्वेश्चन से? पहला देखें कि if the force is A cross V, जब भी ये देखें ऐसा कुछ फॉर्म, what does it tell us? That the force acting on the particle is always perpendicular to the velocity vector. Always, at all times, it's perpendicular to the velocity vector. What does it mean? Well, it means that it does not have any component in the direction of the velocity. What does that mean? Well, it means that will not be able to change the magnitude of the velocity. Why? Because there is no component in the direction of the velocity. But it will change the direction. It will change the direction. It will keep changing the direction. What does this mean in this scenario? The particle will move along a circular path. Right? And what is the direction of the force? A cross V. So if A is a vector in the horizontal plane, then A cross and V to begin with was also in the horizontal plane. Then A cross V or V cross A will be in the vertical direction. Right? And if the particle happens to be in the equilibrium, I think something else is given here. It says V is equals to constant. अच्छा, तो ऐसा करते हैं, rather than me speculating, we'll look at the question. But anyway, we should have fun solving such types. So let's do JEE Advanced question itself. Not this one. Oh, that's not it. Let's see if we can find another good question here. Let's go through this one. It says it is easier to pull a heavy object than to push it on a level ground. Agree, disagree? It is easier to pull a heavy object than to push it on level.
The force is not strictly horizontal.
No, the force is at an angle, right? So at what angle, it's up to you. It can be horizontal, it can be.
So then, I think statement 1 will be true, but so statement 2 will not be the correct reason or explanation. Statement 1.
So when they both the forces push and pull, right? Pushing and pulling is, this is pull, this is push. When the pulling and pushing are both horizontal, in that scenario, both the forces required will be the same. Yes? Correct, Namita? But if they are
Yes.
at an angle, then obviously pulling is easier. Why? Because a component of the force is actually reducing the frictional force. How? If the component of the force in the vertical direction is countering the gravitational, so it's reducing the normal force, hence reducing the frictional, the dynamic frictional force. Remember, the body is moving here. That's why the dynamic frictional force. So mu n is reducing when n is reducing. In the other scenario, it's more like you are digging into the surface, into the ground. So you're increasing your the net force in the downward direction. That means the normal force between the ground and the object is going to increase. So the frictional force will increase. Right? So next time you have the choice, you better pull, not push. Okay. Next one, statement 2. The magnitude of the frictional force depends on the nature of the two surfaces in contact. Yeah, yes. Right? Does the 2 explain the 1? Not really. Yes, Kataji?
Yes, sir.
By the way, it's the coefficient of the frictional force that will depend on the. Hold on. It says, let me visit this question. Apologies for that. Now, the magnitude of the frictional force depends on the nature of the two surfaces in contact. Well, it's
So,
yeah.
so but it's not different between the push and the pull.
Right. But let's revisit the statement 2. Is the statement 2 entirely correct?
So is it like talking about thing like magnitude itself does not depend on the directly doesn't depend on the nature, it's the coefficient that depends.
It depends. So if the body is not moving, body is stationary, then how what is the magnitude of the frictional force? Well, the amount of force that you're pushing it with. If there is a book lying on the table, nobody is pushing it, right? Then what is the force? Zero. If you start pushing it with your little finger, then there might be some force equal to the force you are applying there, right? If you are pushing it with all your might, then the frictional force will be larger, right? It's only the limiting frictional force. The maximum frictional force will depend on mu, which depends on the nature of the two surfaces in contact. Would you guys agree, disagree?
Sir, I didn't get the reason why statement 2 will be incorrect.
And that's interesting. Well, I think I'll tend to disagree with the solution given here. Let me explain what I mean by it. It's talking about the magnitude of the frictional force, right? It doesn't say the body is moving or not. If the body is stationary, what is stationary? What is the magnitude of the frictional force? Zero. If you push it slightly, right, and you have not reached the limiting condition of about to slip, then how much is the frictional force? Well, it's equal to the force applied, right? Right, Ruchika?
Yes, sir.
There is a slight ambiguity, but looks like this should not be correct. So I'll go and try and figure out the correct answer if available on the JEE Advanced site, but shouldn't be correct. In any case, let's move on. Concepts are clear, no, beta? We have another few minutes, so let's solve this one. So we have to figure out the coefficient of friction as the function of angle theta. Small watch out. Note that the particle is moving along a circular path now. If a body moves along a circular path, what do we have? We have a centripetal acceleration. What is centripetal acceleration? It is the radial acceleration pointed towards the center of the circle, right? So your equation will not be summation of all the forces perpendicular and along the incline are zero. No. Your equation along the radial line would be sum of all the forces, the net force in the radial direction pointed towards the center should be equals to mv square by r. And they'll give you the normal force. Once you have the normal force, you can figure out the frictional force, which will be mu times the normal force. And that should be equals to mg sine theta at all times. Because there is no acceleration along the incline. There is no acceleration along the incline. Speed is the same. The acceleration is only in the radial direction. कुछ डाउट हो तो बताएं बेटा.
No, sir, clear.
What is the answer then?
Sir, B option.
Okay. Shavi beta, shall I solve it quickly? Don't write it mg minus cos theta, mg cos theta minus n equals to mv square by r. नहीं, जिस डायरेक्शन में एक्सेलरेशन है आप सम ऑफ द फोर्सेस उस डायरेक्शन में पॉजिटिव माने और all the forces in that direction minus the forces pointed in the opposite direction. So that gives us n. Now along the incline there is no acceleration, so the forces must be balanced. And I'm going to write mu n as the frictional force. Why? Because the object is sliding, so we have dynamic friction. Only in the static friction do we have to worry about magnitude of the static friction force. So mg sine theta must be equals to mu times n, which is m g cos theta plus v square by r. I'm going to write capital R because that's what the answer says. So we get the option B, form B. Yes, beta?
Yes, sir.
Shavi, clear, beta?
Yes, sir.
That's it, beta. So we'll take a break now and resume the class tomorrow. Tomorrow we don't have the class tomorrow, right? So we have the class.
So we have chemistry tomorrow.
Yeah. Chemistry will not change the timings, by the way. So chemistry timings will be the same. Physics timings is what you guys let me know. Whether you guys want to occupy that premium slot. That is what I call as the premium slot. Okay? ठीक है बेटा?
Yes, sir.
Alrighty, beta. See you guys tomorrow.
Thank you, sir.
Alrighty. Take care, baby. Bye-bye. Bye, beta. Bye.